And we also have discussed inverse of the matrix. Say yes or no. I think I had given a problem to find A plus B based on the inverse. How many of you have done it? What is the answer? Ma? 7 by. So if I have given you any problem or the previous week content has to be done, minimum 5 times you need to practice. Okay. Whether do it on the rough work or on a slate or on a board, whatever it may be, you need to do it for 5 times. Then you can easily understand and you can attempt the questions either in the academics or in the competitive exam without doing any mistake. Okay. So practicing many more times makes you the master in that particular aspect. ఓకే ఇప్పుడు నేను ఇంతకుముందు చెప్పాను కదా క్రికెటర్స్ సంవత్సరంలో ఒక 50 రోజులు ప్రొఫెషనల్ క్రికెట్ ఆడతారు. ఈ మధ్య ఐపీఎల్ వచ్చింది కాబట్టి ఇంకొక 50 రోజులు ఆడతారు. మొత్తం 100 రోజులు పోతే ద రిమైనింగ్ 265 days దే నీడ్ టు ప్రాక్టీస్. ఆ ప్రాక్టీస్ అనేది లేకపోతే దే కెనాట్ డూ ఎనీథింగ్. ఓకే, so you are also in a professional course, you are doing a professional degree. You also need to think that you are a professional and whatever you are doing, you have to make it practice for several times. The same thing, till it will be registered in your mind in a positive way so that you can avoid the negative marks. Say yes or no. Right. So how many of you have done that last week? I don't know. At least this week or onwards, you just try to make a practice like that. ఇంతకుముందు వారం చెప్పాను. I don't know how many of you have done it. Now, today we discuss about rank of the matrix, which is very important, which you have to do it. You need to find the rank and applications of the rank of the matrix. In order to find the rank, what is the rank? Can somebody say the definition of the rank of the matrix? What rala? Cheppandi, tondaraga cheppandi. What is the rank of the matrix? Sir, క్లాస్లోనే ఉన్నానండి. వాటర్ అన్న అవి పంప. ఓకే. The determinant can be obtained only for square matrices. Am I right? Whereas rank can be obtained for any type of matrix. You can find it for either rectangular matrix or square matrix or null matrix, whatever it may be. Okay. So what is the rank of a matrix? Cheppamma. Gate varaki separate ga pettandi. Yes. You are writing it in a combined manner. Separate notes rayali. Okay. So gate type of problems different guntai. Your academic problems different guntai. రెండు కలిపి రాసేసావు, అవునా కదా? సో అందుకోసమని సపరేట్గా రాస్తే మంచిది. రైట్. See, if you have given a matrix A is of order m by n, listen all of you. In order to find the rank of the matrix, we have to know about minor of order R. What is minor of order R? Just keeping R number of rows and R number of columns, deleting the remaining, you will get a submatrix. Okay, you will get a submatrix. What is submatrix? In the given matrix, if you delete some rows and columns, keeping some number of rows and some columns, the matrix obtained is known as submatrix. Okay, if you just keep R number of rows and R number of columns by deleting all the remaining rows and columns. Okay, find the determinant of that submatrix of order R by R. The determinant of that submatrix of order R by R is known as minor of order R, because that's why we call it as minor of order R. Okay, say for example, if we have the matrix 1, 2, 3, 4, 5, 6, 7, 8, 9, delete this row and this column and this row. 1, 2, 4, 5. This is one submatrix. Okay, what is the determinant of this one? 5 minus 8 minus 3. This is minor of order 2. If you find the determinant for the entire matrix, that is minor of order 3. Okay, only one minor of order 3 for this one. Now, if you find the determinant of this submatrix, minor of order 2, that is minus 3, as I said. Now I am finding the determinant for this submatrix, 5, 6, 8, 9. 9 into 5, 45, minus 48. 45 minus 48, what is the determinant? Minus 3. What is this one? Determinant of this one? 12 minus 15. Oh, you are getting again? But if you take 1, 3, 7, 9, deleting this one and this row. What is the determinant? 9 minus 21. What is 9 minus 21? Minus 11. Minus 12. Okay, minus 12. Okay. You are having same order submatrices, but their determinant values are different. Their determinant values are different. So you are going to get minor of order R, same order, but the determinant values or the minor values are different. So for any given matrix, there exists different minors of order R. There exist different minors of order R. Is it okay now? Up to this, you can write now. You can write. Let capital A equals to A is A. Let capital A equals to A is A. మీరు ఈ క్లాసేనా? మీరు కూడా రాయాలి నోట్స్. రాయండి. తీయాల. నోట్స్ తీసుకొని రాసుకోండి. A is A of order M by N, of order M by N, by deleting some rows and columns, keeping R number of rows keeping r number of rows smaller number of rows and smaller number of columns. Smaller number of columns. There exists a submatrix of order R by R. R by R. The value of thus obtain submatrix determinant. The value of thus obtain submatrix determinant is known as minor of order R. Minor of order R. Minor of order R. Minor of order R. Okay. Say yes or no? Right, next another sentence in that same definition. There exists different minors there exists different minors of same order for any given matrix. For any given matrix. For any given matrix. For example, just note this one. Take this, consider this matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. Order 3 by 3. Determinant 1, 2, 4, 5 is equal to 5 minus 8 minus 3 is a minor of order 2. A minor. Minor means value. It's a determinant of a square submatrix. A minor of order 2. And 1, 3, 7, 9 is equal to 9 minus 21 minus is another minor of same order. Another minor of same order. Another minor of same order. Okay. So in this manner, there exist different minors of same order. Now I'm going to consider minor of order 1. If you consider minor of order 1 for this matrix, this is 1 by 1 matrix. What is the minor value? Only 1. What is the minor value for this? What is it? 2. What is this? In the same manner, minor of order 1s are also different. There exists different minors of same order for the given matrix. Okay, there exists only one submatrix of order 3 by 3. So there will be only one minor of order 3. That's enough. Clear? Now, after knowing this, what is the rank? Write down. The rank of a matrix, capital A, rank of a matrix, capital A, is said to be smaller if there exists there exists at least a non-zero minor, if there exists at least a non-zero minor, a non-zero minor of order R, a non-zero minor of order R, and all the minors and all the minors all the minors all the minors of order greater than R, all the minors of order greater than R, greater than small r, greater than small r, are are zeros. All the minors of order greater than small r are zeros. Are zeros. Okay. So then you can say rank of A is said to be smaller. We denote it as row of A equal to small r. This is for rank. This is the notation of rank. Row of A equal to row of A equal to small r. Is it clear? Say yes or no. Right. So now let me give you some few simple examples so that you can easily identify the rank of the matrix. Okay. Say yes or no. Right. Tell me, let it be A1, 1 0 0 0 1 0 0 0 1. What is rank of A1? What is rank of A1? Amma? Rank of A1. It is of order 3 by 3. Maximum submatrix that you can get, it is only of order 3 by 3. Maximum submatrix or the submatrix of maximum order. Only 3 by 3. Say yes or no. Right. You have got this? 3 by 3. Now, what is the determinant? 0 or non-zero? Not equal to 0. So what is the rank? 3. There exists a non-zero minor of order 3. and you don't have any minor of order 4, 5, 6, 7, and so on. You don't have those. They are not existed. The only existed highest order submatrix is only of order 3 by 3. Its determinant is not equal to 0, hence its rank is 3. Clear? Now tell me about this. Note down. While I am writing it, you please note down. A2 equals to 1, 0, 0, 0, 1, 0, 0, 0, 0. What is rank of A2? Rank of A2? Huh? 2. Because the determinant of this matrix is 0. There exists only one submatrix of order 3 by 3. Its determinant is 0. So all minors of order 3 are zeros. All minors of order 3 are zeros. Zeros are not. Say yes or no. Clear? Right. Now, what you can say? There exists a non-zero minor of order 2. 1, 0, 0, 1. What is the determinant of it? Non-zero. There exists a non-zero minor, a non-zero. Only one is enough. A non-zero minor of order 2. Of order 2. So rank of A2 equals to 2. Next, A3 equals to 1, 0, 0, 0, 0, 0, 0, 0, 0. What is rank of A3? What is it? Only because all the minors of order 3 are zeros. All the minors of order 2 are also. Take any submatrix of 2 by 2. The determinants are all zeros. So there is only one by one submatrix whose determinant is not equal to 0. So rank of A3 equals to 1. Okay. Again, if I take like this, A4 equals to 0, 0, 0, 0, 0, 0, 0, 0, 0. What is rank of A4? 0. The rank of any null matrix is 0. Note all these 4 examples. Now you can write some conclusions on it. Have you written? Say yes or no. Okay. Now write down a note. Note number 1. If if all the minors of order R of a given matrix are zeros, then its rank is if all the minors of a given matrix of a given matrix of order R are zeros. Of order R are zeros. Then its rank is. Then its rank is. Then its rank is. Tell me, is it equal to R, less than R, less than R equal to R, greater than R equal to R? What I said, you just observe it and refer the previous given examples. Refer them. What I am saying is, all the minors of order R are zeros. Once again, I repeat, all the minors of order R are zeros. Refer the given examples. What are the examples? All minors of order 3 are zeros. Okay. Is it equal to 3 or greater than 3? Tell me, what is the rank? All minors of order 3 are zeros. Okay. Now, what is the rank? Is it equal to 3 or greater than 3? It is not equal to 3, not greater than 3, but less than. Okay. Here also all minors of order 3 are also zeros. Okay. So what is the rank? Is it equal to 3 or greater than 3 or less than 3? Less than 3. All minors of order 3 also zeros. All minors of order 3 also zeros. What you can say? Less than 3. Here it's not so. So if all minors of order R are zeros in any given matrix, what is the rank of it? Is it less than 3, less than R equal to 3, equal to 3 or greater than? Less than R. Can you read the sentence once again? Read the sentence loudly. If all the minors of order R are zeros, then its rank is less than R. If you are going thorough about this one, you can write that statement very easily. Clear? Yes or no? Right, next, another one. If take if there exists a non-zero minor of order R for any given matrix, if there exists a non-zero minor of order R for any given matrix, there exists a non-zero minor of order R for any given matrix. Then its rank is, then the rank of the matrix is, yes, Amma? What is the rank of the matrix? there exists a non-zero minor of order 1. What is its rank? Is it 1 here? 1, 3. So again, there exists a non-zero minor of order 1. Is it 1? The rank of this matrix is 1. No. There exists a non-zero minor of order 1. What is the rank? Maybe 1 or more than 1, more than 1. So if there exists a non-zero minor of order, if there exists a non-zero minor of order R for any given matrix, for any given matrix. What is the rank of the matrix? Then the rank of the matrix is greater than or equal to small r. Greater than or equal to small r. Say yes or no. Is it clear? So in order to write such statements, I had given these examples. Okay. So these kind of things will be asked and were asked in the previous examinations related with rank. Now again, we have, we need to find the rank of the matrix. Always whenever any given matrix is given, finding the minors and then going ahead along with such kind of things. That means finding the determinants of those 2 by 2 or 3 by 3 or 4 by 4 and so on. It takes time. It takes time. So what we have to do and what is the procedure to find the rank of the matrix? In order to find the rank of the matrix, we use some transformations, not operations. For finding the determinants, we use for finding the determinants, we use operations. All the properties, almost 11, you have written, and some more we have written as problems. Here, in order to find the rank, we are going to write the transformations. Okay? Row transformations or column transformations. Write down row or column transformations. Row or column transformations. Row or column transformations. Okay. Interchanging the rows, ith and jth rows. Interchanging ith and jth rows. Or interchanging ith and jth column. Interchanging ith and jth column. Interchanging ith and jth column. Ith and jth column denoted by Rij or Cij. This is one transformation. Okay, one row transformation or column transformation. క్లియర్ రాస్తున్నావా వెనకాల చక్కగా స్టాండ్ వేసినావు స్టాండ్ వేసేసి అట్లా కూర్చుంటే ఆర్ యూ రైటింగ్ ఆర్ నాట్ రైట్ గుడ్ యువర్ నోట్స్ విల్ బి వెరిఫైడ్ by the faculty members or sometimes myself or sometimes another faculty. మీ నోట్స్లు ఖచ్చితంగా వెరిఫై చేస్తారు. మిమ్మల్ని మీరు చీట్ చేసుకోకండి. అర్థమైందా? ఇట్ ఈస్ యువర్ క్లాస్, యువర్ ఫ్యూచర్ అండ్ యువర్ మనీ. For you itself, we are doing all these things. Particularly the management is doing all these. Okay, whatever I am explaining, whatever I am writing on the board, you try to note it and practice it. That will gives you a bright future. Otherwise, it is up to you. Next, multiplying a non-zero scalar k to any row or any column. Multiplying a non-zero scalar k, a non-zero scalar k to any row or any column, denoted by KRI. R slash means R. KCI. KCI. Next, multiplying ith row with a non-zero scalar k and added to the corresponding elements of zth row. Added to the corresponding elements of zth row, or multiplying any column or ith column with a non-zero scalar k and added to the corresponding elements of zth column. Okay, Amma, these three are known as transformations, row or column transformations. By applying this or by doing these transformations, the rank of the matrix will not be changed. The rank will remain same. Rank of the matrix will remain same. Okay, so we are going to use this. By using these transformations, how does the matrix will become? That also I'll tell you. Okay, first of all, write down by the row or column transformations. By the row or column transformations. By the row or column transformations. Row or column transformations. The rank of the matrix remains the same. The rank of the matrix remains same. The rank of the matrix remains same. Okay, so that's why you can do any of such kind of things. What's the use if you have given an n by n matrix or a 4 by 4 or 6 by 6 matrix or 7 by 7? By applying the row or column transformations, try to reduce it into such form. Which form? This is known as normal form. This is known as normal form. Try to keeping an identity matrix in that, and all the remaining are zeros. Okay. If you apply row transformations, then the given matrix will become upper triangular matrix. By applying column transformations, the given matrix will be reduced into a lower triangular matrix. By applying both, it will become a normal form matrix. Okay. So that upper triangular or lower triangular forms are also known as echelon forms. Okay. Have you written that previously? Say yes or no in academics. Have you written or not? Write down. By applying row transformations, row transformations, row transformations, by applying row transformations, the given matrix Aij of order m by n is reduced into upper triangular form. Upper triangular form. Upper triangular form matrix. Upper triangular form matrix. Next, this is by row transformations. By column transformations. By column transformations. By బాబు ఏంటి నువ్వు అటు ఇటు తిరుగుతున్నా మార్చ్ ఫాస్ట్ చేస్తున్నావు వన్స్ క్లాస్లోకి వచ్చినప్పుడు కూర్చోవాలా ఆర్ యూ రైటింగ్ ద నోట్స్ ఆర్ నాట్ కోఆర్డినేటర్ అంటే క్లాస్ కోఆర్డినేటర్ మేడం ఈ ఇయరేనా and then also you try to write the notes right by applying column transformations the given matrix will be reduced into lower triangular form matrix. Lower triangular form matrix. Okay. These two forms are known as echelon forms. Echelon forms. So you might have already known about this echelon form, reducing it into that echelon form by applying either row or column transformations. If you apply both, write down. By applying both both row and column transformations, row and column transformations. The given matrix AI is a of order m by n can be reduced into IR 0, 0, 0 of same order m by n. IR 0, 0, 0, which is known as normal form. Amma, this is known as normal form. Normal form. What is IR? Cheppali, what is IR? I ante enti? Almost we have 2 sessions over. What is I? Identity. IR means identity matrix of order R. Write down. Where IR is identity matrix of order R. Identity matrix of order R. Okay? Right. See here, if you have given a matrix and using several row or column transformations, it is becoming as matrix B. It is becoming as matrix B. Okay. We write this A is equivalent to B. If A is of order m by n, B is also of order m by n. Now, applying the row or column transformations, you are getting B. In this case, if the rank of A is R, rank of B is also R. Both will be of same order and the same rank. Such matrices are known as, what we call them? Such matrices are known as, ఏంటమ్మా చెప్పు ఏంటి? Which part of yoga that you are practicing in the morning? It is almost 10. Okay. I asked her why you are responding. Are you working as personal assistant to her? Huh? Don't give your answers. Okay. మీ ఆన్సర్లు ఉంటే లోపల అణిగి తక్కువాలి. అమ్మా, you respond, please. I had a doubt. You are in yoga. What you call that yoga position? What is the position? What you call that position? No answer. Okay. Early morning ante it's almost only 1 hour we have started the session. Okay. Don't practice yoga. Emma? Right. Write down. What we call those? If the rank is same for both the matrices, order is also same. What we call them? We call them as equivalent matrices. Previously we have discussed equal matrices. What are equal matrices? Same order, elements in similar positions are same. But here it is not so required. Elements in similar positions need not to be same. When order and rank both are same, for two different matrices, they are called as equivalent matrices. Write down that definition. Equivalent matrix. equivalent matrices. Equivalent matrices. Two matrices capital A and capital B, capital A and capital B are said to be equivalent if one can be obtained from the other, if one can be obtained from the other by a sequence of by a sequence of by a sequence of row or column are both transformations. Row or column are both transformations, are both transformations, both transformations. Okay, right? You may apply both. But even though rank will not be changed, order will not be changed. That is, that is, that is for equivalent matrices, both will have same order, both will have same order, and both must be of same rank. Both must be of same rank. Both must be of same rank. Same rank. Okay? Clear? Have you written this? This is the symbol for equivalency. Okay. Equal means two horizontal lines. Equivalent means you just flip that yes. ఎస్ నేమ్ చేస్తారు మా పనుకోబెట్టండి. Try to write that S in a horizontal position. You will get equivalency symbol. Right. Now here, if there exists a matrix of order m by n, whose rank is smaller? Write down. If you are having a matrix, capital A of order m by n, whose rank is smaller? Whose rank is smaller? Ma. Then there exists two non-singular matrices. Then there exists two non-singular matrices P and Q such that what is the order of PM? M by M. What is the order of Q? Q order. What is the order of Q? What is the order of Q? Huh? What is the order of Q? n by n. There exist two non-singular matrices P and Q such that P into A into Q equal to IR 0, 0, 0 of order m by n. Okay, write down. Let capital A be a matrix of order m by n. Capital A be a matrix. Capital A be a matrix of order m by n with rank small r. With rank small r. With rank right లను అక్కడేంటి నేను చెప్పింది వస్తుందా? వాట్ ఇస్ దట్ దెన్? ఇదే క్లాసా నువ్వు కాదా? ఈ క్లాస్ కాదా? ఓకే. With rank small r, then there exists two non-singular matrices. Then there exists two non-singular matrices such that P into A into Q equals to IR 0, 0, 0. Okay. Which is known as normal form. Which is known as normal form. Okay. Now here P is of order m by m. Q is of order n by n. P is of order m by m and Q is of order n by n. Q is of order n by n. Say yes or no? Clear? Right. Now, if any matrix can be written into such normal form, it is of with rank small r, or any matrix with rank small r is there, you can write it into such normal form. Vice versa. Write down that. Another note or a result. This is fourth one, I think. This is one result and another second one. After equivalent matrices definition. If any matrix of order m by n with rank small r, with rank small r, in the sentence, don't write if in the beginning. Don't write if, just strike it up. Any matrix, okay, any matrix with rank of order m by n with rank small r can be expressed as IR 0, 0, 0. IR 0, 0, 0. Of order m by n. Of order m by n. Okay, which is normal form, which is normal form if and only 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 if IR 0 0 0 IR 0 0 0 is obtained by a sequence of row or column transformations by a sequence of row and column by a sequence of row and column transformations, and it is of rank small r, and it is of rank small r. If you have a matrix with rank r, you can write like this. If you are having any matrix like this, it is of rank small r. Okay, there is an if and only if condition related to this. Okay, before writing or before doing some of the previous gate problems, we'll write another different kinds of matrices. Okay, elementary matrices. You just write elementary matrices. Elementary matrices. Ma, listen. You are having an identity matrix 1 0 0 1, right? I am going to interchange R1 2. What is it? Speak out. What is it? I am interchanging first and second rows. What is it? అమ్మా 1001 ఇంటర్చేంజ్ చేస్తే మళ్ళీ 1001 వస్తుందా? 01. Good. So again, if you are writing C12, what you are getting? Ma 01. Good. If you are writing KR1, equivalence. This is equivalent symbol. KR1, what is it? First row to be multiplied by a non-zero scalar. K0, 0, 1. Next, R1 plus KR2. Whatever we are writing in the first, to that row only you have to do the transformation. Multiply second row with K. Add it to the corresponding elements of first row. What you are getting now? 1 plus 0 into K. 1. Next, K. Next. So in this manner, you can write different matrices by a row or column transformation. A row or column. I'm not saying a sequence. Only one row transformation or only one column transformation. These are known as elementary matrices. These are known as elementary matrices. Okay, రాసి అట్లా రాసుకోండి. Then I'll tell you the definition. Either row or column, only one. Either row or column. Write down. The matrix obtained from an identity matrix. The matrix obtained. The matrix obtained from an identity matrix. From an identity matrix by a row or column transformation. By a row or column transformation. By a row or column. ఇది ఎందుకమ్మా ఇది మూసే. By a row or column transformation. By a row or column, only one. That is only one transformation is known as elementary matrix. Is known as elementary matrix. Elementary ఏం రాలే తొందరరా వెళ్ళి చెప్పరా. Is known as elementary matrix. Elementary matrix. Okay, we are going to get several elementary matrices. Amma, several elementary matrices for the given identity matrix. If it is 2 by 2, you can write so many. How many we have written? 4. You may write n number. By a different transformation, you may get one matrix. Okay. Say yes or no. Right. Ma, these are elementary matrices. So far we have discussed equal matrix. Equal, equivalent, elementary. You need to observe the difference. All are having same order, but similar elements in similar positions, same. That is equal. Okay. Same rank. That is equivalent. And next, obtaining from identity matrix by only one row or column transformation is elementary matrix. Okay. So if you have given a matrix, capital A, write down, related to this, there you can write a property. Let కూర్చో వాళ్ళిద్దరు కూర్చో ఏమొద్దు కూర్చో 3 hours అయిపోయేంత వరకు కదలకూడదు కూర్చో నేను ముందే చెప్పా గేట్ క్లాస్ అంటే 3 hours అయ్యేంత వరకు కదలొద్దు ఇఫ్ ఇట్ ఈస్ రిక్వైర్డ్ అవసరమైతే ఎమర్జెన్సీ అయ్యి మీరు పడిపోతున్నారంటే అంబులెన్స్ని పిలిపిస్తారు వాళ్ళు వచ్చి స్ట్రెచ్చర్లో తీసుకెళ్తారు ఏమ్మా నువ్వేంటి వాటర్ బాటిల్ తీసుకొని లేచిన ఆయనకా ఆయన please note, let we are going to write a property related with the elementary matrix. Before writing that entire general statement, I am going to give you a simple example. A1, A2, B1, B2. Listen. Turn this side. Next to red shirt. Next to red shirt. Turn this side. Yes, this side. నేను ఎవరినైతే అడుగుతానో ఆయన ఖచ్చితంగా అటు ఇటు చూస్తూ ఉంటాడు. మిగిలిన వాళ్ళందరూ నన్నే చూస్తారు. ఓకే, హియర్ there is one elementary matrix. We have an elementary matrix 0 1 1 0 multiplying with this. If you multiply this elementary matrix with this, we call it as pre-multiplication. P-R-E, PUC, intermediate ఇంతకుముందు PUC అనేవాళ్ళు, pre-university course, after graduation, post-graduation. If you're multiplying with that afterwards, we call it as post-multiplication. This is pre-multiplication. Now just do the multiplication. What you are getting? 0 1, that is B1. Next 0 1, that is B2. Next A1, next this is 0. Next A2. What is the transformation that is occurred here? R12 is this. By pre-multiplying an elementary matrix to the given matrix, it results the corresponding row transformation. If you do the same thing, A1, A2, B1, B2 with the same thing, 0 1 1 0, what you are getting? Multiply. What you are getting? Yes, what you are getting? A1 into 0, A2 into 1, A2. Next, B1 into 0, B2 into, are you getting it or not? A1 into 1, A1. Next, this one is B2. Next, what is the transformation that is occurred here? What is the transformation? Columns were interchanged. C1 2. This is row transformation. This is column transformation. If you do the pre-multiplication of an elementary matrix to the given matrix results the corresponding row transformations. Post multiplication of an elementary matrix to the given matrix results the corresponding column transformations. Okay, right up. The pre-multiplication. The pre-multiplication the pre-multiplication pre-multiplication of an elementary matrix to the given matrix pre-multiplication pre-multiplication of an elementary matrix to the given matrix results the corresponding row transformation in the given matrix. Row transformation in the given matrix. Write the first one. 0, 1, 1, 0. A1, A2, B1, B2 equals to B1, B2, A1, A2. Next. The post multiplication of an elementary matrix. The post multiplication of an elementary matrix to the given matrix. The given matrix results the corresponding column transformation in the given matrix. Corresponding column transformation in the given matrix. Okay. Now down that second one. A1, A2, B1, B2, 0, 1, 1, 0 equal to A2, A1, B2, B1. Corresponding column transformation. Is it clear? Say yes or no. Right. We discuss some simple properties of the rank now. The rank of any given matrix is equal to its transpose. First one. The rank of any given matrix is equal to rank of A transpose. Rank of its transpose. Next. Rank of A plus B. Rank of A plus B. What is rank of A plus B with rank of A and rank of B? Amma, don't be get mug up the things, by heart the things. Take an example, verify it, then you can write the statement easily. If A equals to 1, 2, 3, 4. B equals to 1001. Rank of A is how much? 2. 4 minus 6, non-zero. Rank of B? What is rank of B? 2 only. Okay, what is A plus B? What is A plus B? బాబు ఇదేంటో చూడండి. ఏమైంది?